Hello everyone. Today we have Pre-Calc lesson 37. We're going to talk about the line as the locus and the midpoint formula. I want to remind you of the distance formula. We are going to put it into application today, so if you don't know it, you need to memorize it. We have y2 minus y1 squared plus x2 minus x1 squared. It doesn't matter the order. If you want to do x first, then y, or whatever, it doesn't matter. Okay? Now, what we did before is we found the distance between 4, 2, and xy, right? And it was this expression that was x minus 4 squared plus y minus 2 squared. Okay? Now, we're going to talk about a line as a locus, and then we're going to combine that with the distance formula. Okay, what does that mean to be a locus? The definition of a line is the locus of all points. Locus is like location in a plane that are equidistant from two specified points. Okay, so what does that mean? If I have this point here, let's call it xy, and I have this point here, zw, the line is the distance of all points that are equidistant from here and here. Okay, so now why do we care about this? This is what we are going to do. Okay. Find the equation of the line that is equidistant from the points 4, 2, and -2, -3. Okay, so the first thing that we need to do is we are going to find the distance from both of these points to the point xy. Okay, so the distance from 4, 2 to xy we know is x minus 4 squared plus y minus 2 squared, and the distance from -2, -3 to xy is the square root of x minus a -3 squared plus y minus, x minus a -2 and y minus a -3 squared. Now I set these equal to each other because the definition of a line is equidistant, right? The equation of the line that is equidistant from these points. So the distance from here to here is the same as from here to here. So I set them equal to each other. Now I'm going to find the equation of my line. So I'm going to square both sides, which takes away my square roots, giving me x minus 4 squared plus y minus 2 squared is x plus 2 squared plus y plus 3 squared. Now I have to square out each of these terms. Now it is easiest to do a quick little trick. So here is a side note. X minus 4 squared, we square the first term, x squared. Then we multiply these two terms together and multiply it by 2. So this becomes minus 8x, and then you square the last term. Now, you can do it as x minus 4 times x minus 4 and FOIL it out each time. That's totally fine. Or you can do the shortcut way. So, back to here. My first term, I have x squared minus 8x plus 16. Now this term, I will have y squared minus 4y plus 4 equals, over here, I have x squared plus 4x plus 4 plus y squared plus 6y plus 9. It's much faster to use this little trick than it is to square it out each time. But you can do it, doesn't matter. Now, let's look on both sides. I have an x squared term on both sides, so they cancel. And I have a y squared term on both sides, so they cancel. Now I want to get my y's on one side, so I'm going to bring this y over. Okay, so I will have -8x plus 16 plus 4 plus 20 equals, now I have 6y plus 4y, so 10y plus 4x plus 13. Okay, I'm going to bring my x term over. So I have negative 12x. I'm going to bring this 13 over, so plus 7 equals 10y. Now divide everything by 10. So I get y equals negative 12 over 10x plus 7 over 10, which I can simplify. Y is negative 6 over 5x plus 7 over 10. This is the equation of the line that is equidistant from both of these points. Okay, these are kind of lengthy problems, so you have to make sure you don't make mistakes along the way. All right, let's do another example. Find the equation of the line that is equidistant from 0, negative 4, and 5, 2. Okay, now your book will most likely specify that they want the equation in slope-intercept form, like I did in the last problem, which is y equals mx plus b. But when in doubt, if it doesn't specify, then leave it in slope-intercept form. All right, so I'm finding the distance from both of these points to x, y. So the first distance, I have x minus 0 squared plus y minus a negative 4 squared equals the square root of x minus 5 squared plus y minus 2 squared. I square both sides to get rid of my square root. So this leaves me with x squared plus y plus 4 squared is x minus 5 squared plus y minus 2 squared. Now I need to FOIL out each of these, so this gives me x squared plus. I'm going to use my trick where I square the first term, multiply them together, and multiply it by 2, and then square the last term. So I have x squared minus 10x plus 25 plus y squared minus 4y plus 4. Alright, now when you do this, your x squareds and your y squareds should cancel. So I have x squared on both sides and y squared on both sides. Alright, so I have 8y plus 16 is negative 10x minus 4y plus 29. Okay, I'm going to bring my y term over, and I'm going to bring my 16 over. So I will have 12y equals negative 10x plus 13. And I'm going to divide everything by 12, so I get y is negative 10 over 12x plus 13 over 12. And then I simplify y is negative 5 over 6x plus 13 over 12. Okay? That is how you find the equation of the line equidistant between 2 points. Now let's talk about a new formula, the midpoint formula. It's a point, okay? It is the point that is halfway between two others, and in this case I'm going to show you between x1, y1 and x2, y2. Okay, so your x term is the average of your x's, x1 plus x2 over 2. Your y term is y1 plus y2 over 2. And then you write it as an ordered pair. So we get x1 plus x2 over 2 and y1 plus y2 over 2. Okay, that is your midpoint formula. Much easier. So let's do an example. Find midpoint between negative 2, 6 and 4, negative 10. So it's a point. I do x2 or x1 plus x2 over 2 and y1 plus y2 over 2. I simplify, so negative 2 plus 4, I have 2 over 2. 6 minus 10, I have negative 4 over 2. This leaves me with 1, negative 2. That is my midpoint. Okay? All right, that is all for this lesson. I hope you have a fantastic rest of your evening.